Today in IM1, we're going to talk about linear inequalities. This is Unit 5.6. So Coach Carter is analyzing the scoring patterns of a few players on his basketball team. Looking at Maria, he notices that she's been averaging 20 points per game from scoring 2-point and 3-point shots. If she scores 6 2-point shots and 2 3-point shots, will Maria meet her points per average game? So we can just go ahead and say 6 times 2 plus 2 times 3, and that would be 12 plus 6 equals 18, because it's 6 for each 2-point shot, 6 of those. And so the answer is no. She will not reach her points per average game. Let's do another scenario. If she scores 2 7-point shots, so that would be 7 times 2, plus 2 3-point shots, so 2 times 3 would be 14 plus 6. And the answer is yes, she would meet her average, 20 points per game. Okay? One more. If she scores 7 2-point shots, so 7 times 2, and 4 times 3-point shots, that would be 14 plus 12. The answer is yes again, because she scored 26 shots, and that's going to make her coach really happy. Okay, so she went way over her average. Okay, let's write an equation that represents this whole scenario. So we're going to call the number 2-point shots x, and we're going to call the number 3-point shots y. And we want a total of 20. So we're going to go 2 times x, because they're each worth 2, and 3 times y, because they're each worth y, and that's going to equal 20. So now what I want you to do is graph that equation on the coordinate plane. So remember, if we're in slope-intercept form, it would be, in standard form over here, it's nice to be able to do intercepts. So I'm going to go ahead and do my intercepts. And so I cover up the x, and I get 3 times what equals 20, and this is not nice and even, but we'll just write 6 2/3. And then 2 times what equals 20, that would be 10. So that's our x and y intercept. So that tells us what kind of units we could use. So right away we can make sure we have our x and our y in the right place. And that means we can just go by ones, right? 1, 2, all the way over to 10. So let's just graph that. We're going to make it simple. And there's our equation, our graph and our equation. And we can see that we put the y at 6 2/3. We had to estimate there because it doesn't equal an exact number. So this is our graph. Now, I want to ask you a couple of questions, and I want you to think about this. How would the equation change if we included all of the scores that would meet that goal? So how would the equation change? Oh, well, remember the third problem from the other page. If she hit anything over 20, so we could say greater than or equal to. Okay, that would reach our goal, and the coach would be very happy if she did that. Well, the next question is, how would the graph change? So what would we do to the graph to indicate this equation? And here you go. That would be the equation and the graph. Okay? So if I scored 5 2-point shots, that would be 10. And that would be 8 3-point shots, which is pretty wild, 24. That would get me to my goal because that would be 34 points. And that is greater than 20. And your coach would be very, very excited. All right, so this is just a diagram of what to look for when you're drawing linear equalities. So notice first they're going to talk about the lines. So if you have a line below your inequality sign, then that means that your graph is going to be a solid line. Okay, because that little symbol means equal. Okay, so you look at that first. That's going to give you the solid line. When you have this, it means that the line is not part of the solution, so you'll graph it with a dashed line. Okay, so now we're going to talk about where to shade. If it's greater, if y is greater, you shade above the line. So you shade above. If y is less, and it could be, if y is less, that means less, okay? Then you're going to shade below the line. Doesn't matter if it's whole or dashed. So when you look at your equation, that's telling you where to shade. Below the line, above the line. Okay, so here are the steps to solve a linear inequality. So first, solve the inequality for y. Put it in slope-intercept form. Remember, if it's in standard form, you're going to use your intercepts if the coefficients are factors of your c, right? If the a and the b are factors of c, that's easier. If it's not, put it in slope-intercept form. Then you're going to graph the boundary line like we've been graphing all year. Before you start, stop and think, am I going to be using a solid line because it's one of these, or am I going to be using a dashed line? And you could even draw that next to your equation to give yourself a hint. Then you're going to shade the half plane. In other words, the line is cutting your plane into two pieces. So you're going to shade above for either of those, and you're going to shade below for either of those. Okay? So shade above, shade below. And all of my graphs have these really nice shading. Lines are perfectly okay. All right. So, in the exploration on page 148, it asks you to graph these two equations. So there's the first one. We go to y is 5. My y-intercept is 5. My slope is 1 over 1. So I'm going to go up 1 over 1. And I put a bunch of points, but I noticed that this is going to be a dotted line. So I put that together. And y is greater. So I shade above. Okay, looking at this one, I see that it has an equal, so it's going to be solid, and y is less than, so I'm going to shade below. And it's nice to put it in slope-intercept form for specifically this reason. The y tells you where to shade. Okay, then I'm going to go to my y-intercept, which is 1, right there. And I have a solid line. I'm going to go down 1 over 2. So down 1 over 1, 2, put a point. Down 1 over 2, put a point. Maybe go up 1, back 2, put another point. Use a ruler to draw your line. Now go back and remember, oh, I shade below. So I go like this. Okay, so what's a test point? This is something that helps you figure out if you graphed correctly. For example, if I said this was my graph, but I wanted to check, I could use the point x equals -2 to check my graph, because that's in my shaded area. So I plug that in. Y is greater than or equal to 4 times -2 is -8 plus 2. Y is greater than or equal to -6. That is true, so that means that that is part of my shading. Since that is on this side of the graph, I can know that my shading should be on this kind of a graph, this side of the graph. The easiest test point to use is 0, 0, because plugging it in is really 0. So you just plug in 0 is greater than or equal, 4 times 0 is 0, plus 2, 0 is greater than or equal to 2. Well, that's false. That means that that point is not a solution, and I should shade on the other side, which I already did. So this, using 0, 0 comes in really handy if your equation is in slope-intercept form and you used your intercepts to graph. Then you can just quickly use that to test which side you should shade on. Okay, so this is my example down here of what I want us to do this time. So the first thing it's saying is to determine whether it's a solid line or a dashed line. And that's really easy to do. So we can just go through and look. We can see that A is going to be dashed. Okay, this one has a solid. So we don't have to do anything to the equation to determine this. So I want you to look at them before I do them. This again is a solid. This one is dashed. This one we already see is dashed, and this one would be solid. Okay. All right, now this is the reason why I put this one here, is because I want you to see that it's easier sometimes to put it in slope-intercept form to determine if it should be above, below. So right here I'm looking at this and it says y is greater than, but I don't have it in slope-intercept form, so I can't make that final determination. So the first thing I'm going to do is subtract 7x from both sides. I get negative y is greater than negative 7x plus 12. And then I have to get rid of that negative because slope-intercept has just a y by itself. So divide by negative 1. But when I divide by a negative across my inequality, I have to flip it. So now my equation is y is less than 7x minus 12. And I can see that y is below, so I'm going to shade below. So that's why you want to put them in slope-intercept form or graph them and use a test point. Okay? So we're going to determine with each of these, this is y is greater than, so I know that I'm going to shade above. Okay? Now over here, I'm going to work this one out. 4x minus 5y is greater than or equal to 37. I'm going to subtract 4 from each side, 4x, sorry. I get negative 5y is greater than or equal to negative 4x plus 37. And now I'm going to divide by negative 5. And that is going to flip my sign. And I'm going to get y is less than or equal to 4/5 x. And I'm not going to bother switching this because we're only worried about the graphing. And so you can see it flipped to less than. Okay, let's do C. So we've got x. We're going to subtract the x, so we get 2/3. Y is less than or equal to negative x plus 6. I'm going to multiply every term by 3/2. Okay, and so that gets rid of my y is less than or equal to negative 3/2x plus 2 goes into 6 3 times 9. So right now it's y is less than, so I'm going to shade below. Okay, this one all I have to do is subtract the x, and I'm going to shade below. This one's already done for us, so this one's in slope-intercept form, and it tells me y is less than, so I'm going to shade. Oh, that one was below. Okay. There we go. All right, so tell whether each of the ordered pair is a solution of the inequality. So first thing I'm going to do is I'm just going to plug these in for my x and y. 3 plus 2 is greater than 5. That is false. The answer is no, because 5 is not greater than 5. It's equal to. So that one is no. So be careful with those kind. Then we have 5 minus 3 is greater than or equal to 2. 2 is greater than or equal to 2. It only has to answer one of these, so this one is yes, because this is a true statement. Okay, so I'm going to give you a couple minutes to solve each of those on your own. You just need to push pause, and then I will put the answers up. Okay, so check your answers and see how you did. Go back and check your work if you got it wrong. Okay, so what kind of lines are represented in 7 through 10 in your journal? Okay, So that would be vertical and horizontal lines. So when we're graphing inequalities like this, we want to make sure that we're looking at the line. So it's a solid line and x is less than. Just ask yourself, what numbers are less than 4? Well, this is less than 4 and this is less than 4, so graph it that way. Okay, the next one is a horizontal line. Y is greater than, but it's not equal to, so it's a dashed line. And so think of numbers that are greater than -2. This one, and this one, and this one. And that will help you shade. Okay, so in your journal, you're going to graph number 13 using slope-intercept. So we go to positive, we're going to go to 1, and then we're going to go a slope of up to 3/1. This is a dashed line, so I'm going to make my dashed line, and I am shaded below. There we go. Okay, for this one I'm going to use intercepts because it's in standard form. So I'm going to plug up, remember how we did that, plug up the x value and just solve for 3y. So, and just solve for the equality, because that's what you're looking for, the exact number. So 3 times 2. Then you're going to plug up the y, okay, and you're going to solve for -2x equals 6, and that would be -3. Okay, so now we're going to graph those 2 points, 2 and -3, and this is a dotted line, dashed line, and I'm going to use that test point of 0, 0. Okay, so I'm going to go -2 times 0 is 0, plus 0 is greater than 6. Is that true? No, so that means that is not a solution, and I'm going to graph on this side. So let's see how we did. Okay. All right, we did great. Okay, so what is the equation of this line? So I'm going to go y. My y-intercept is +2, and my slope is up 2/1, so it's y equals 2x plus 2. Okay, so now we've shaded it, so we're going to take that same equation, y, and it's a solid line, so we're going to say equal 2x plus 2, but now it's shaded below, so we're going to say y is less than. Okay, so let's write an inequality to represent this graph. So the first thing I'm going to do is I'm going to see that it's shaded below, so I'm going to say y is less than. It's dashed, so I don't put a line there. My slope is 1/1, but it's negative, so it's -x, and my y-intercept is 0. So if I was going to write that properly, that would be the equation of this line. Okay, so the last problem we're going to do here is number 19, and we're going to think about it carefully. So this is a word problem, so the first thing that we have to do is come up with our variables. So it tells us right here that x is digital cameras, so x equals digital cameras, and y is cell phone. Okay, now it's telling us that they want to make a profit of at least $300. So at least $300 would look like that. Okay, it could be 300, but they'd love it if it was greater. Then we're going to put the value of each of the things. So for digital cameras, they make $100, and for cell phones, they make $50. So before we go on, we've got our equation. We want to make sure that we find our endpoints because we don't know what our units are going to be. Okay? So we're going to use our intercepts and plug up your, plug for x. So we're going to go 50y is equal to 300. So that would give you 6. Okay? Divide 300 by by 50. Then we're going to look at just 100x is equal to 300 because we're just finding our intercept. So this is covering up the 50y. So we're going to divide and we get x equals, whoops, I forgot my zeros, x equals 3. Okay, so now we've found our intercepts. So now we know that our units can be just regular numbers. So x is 3 and y is 6. And we can draw our line, which will be solid, and we would shade above. So let's look at that. And there's your answer. Now, what they're asking you to do when they say find a couple of answers that would be the solution is anything out here. But remember, only whole numbers will work because you can't sell a half of a camera or a half of a cell phone. So any solution on the line that's a whole number, you could actually buy 3 digital cameras and 0, remember what our intercepts represent, and 0 cell phones, or 6 cell phones and 0 digital cameras. But all of these represent solutions that would give us the profit that we want, which is at least $300. Okay, so hopefully that helps. Have a good day.